As we have seen before, this is a parallel in parallel out 4-bit register. The register has 4 flip-flops, flip-flop 0 to flip-flop 3. It has reset and load, which are synchronous inputs, and when the flip-flops are reset, they are going to go to 0 0 0 0, which means when you reset, Q3, Q2, Q1, Q0 are going to be all zeros. Now our task is to write the VHDL code. In fact, we are going to write a VHDL program for an n-bit register. This is a 4-bit register, and we are going to write a generic code. Generic in the sense it should be able to take for any positive value of n. An n-bit shift register looks as follows. Basically, you have 4-bit registers here. If you have n bits, then you're going to have n flip-flops. In a 4-bit register, you have inputs D3, D2, D1, D0 and outputs Q3, Q2, Q1, Q0. In an n-bit register, you have inputs Dn-1, Dn-2, so on up to D0 and outputs Qn-1, Qn-2, Qn-3, so on up to Q0. So your block diagram is going to look as follows. It's reg-n. It has data in, which is n bits wide. It has reset. It has a load and a clock, and it has an n-bit output. I'm going to name it as data out. Basically, your D3, D2, D1, D0 are data in. Q0, Q1, Q2, Q3 are your data out. So let's write the VHDL code. Library IEEE. So let's include the libraries. Use IEEE dot standard logic underscore 1164.all. Ports. So entity reg n is. Now here we are not given the value of n, so that is why we have to write a generic code, and the generic code looks as follows. You have generic, n is an integer, and by default it takes the value 4. If you want to have a 32-bit register, you need to change that to 32. Semicolon. Then you have your ports. So your clock, reset, and load are your inputs. So in standard logic, the next input is data in, which is in standard logic vector n-1 down to 0. So that's n bits, and you also have data out, which is out standard logic vector n-1 down to 0. And entity. Now let's write the architecture. For architecture, we are going to use behavioral modeling. Behavioral modeling is preferred when you're writing larger complex systems because it is much easier to express systems using if and else statements. So architecture, arch of reg-n is begin, process, clock. It's a synchronous system. So if you have a rising edge of the clock, so that's clock tick event, and clock equals to 1, then if reset equals to 0, then data out should be 0. That is, all your queues should be 0, but we do not know the size of n, so we have to write a generic version. And the way we write is, we write data out equals others gets 0. So this makes sure that data n is 0, 0, 0, so on up to n bits. Else if load equals to 1, that is when you load the data, and you simply write data out is equals to data in. We could have done this using structural programming, but that takes a lot of function calls, that is a lot of port mapping. This is one way in which you can avoid port mapping. And if end process, there's another end if end process end architecture. So this is the generic code for an n-bit register.